Hi everyone, welcome to today's workshop. It's called Last Mile of OCR, LLM-Based Document AI, and Hands-on with Agentic Document Extraction. We have Ankit Khare from Landing AI with us today, and we're really excited for the session. Before we begin, just a few quick guidelines. We'd really appreciate if you could stay muted when you're not speaking, and use the raise hand feature if you'd like to jump in. Feel free to drop in your questions in the chat anytime. Our team will be keeping an eye on them. This is an interactive session, so we encourage you to stay engaged and keep your camera on if you're comfortable. And also, the session is being recorded and the resources will be shared with you afterwards. With that, over to you, Ankit.
Yeah, so welcome everybody. Really excited for this session. It's going to be 2 hours. Do you see a beautiful QR code? So that's the key to this session. The API credits that you will need to run with me, you will get using this QR code or this link, okay? So what you need to do is click on it. See, for me, since I'm already logged in, it goes here. For you, it will look a little different, right? So let me open an incognito, paste here. And then once you paste it here, uh, click on sign in.
Ankit, can I ask a question?
Yes, for sure.
All right. My org policy doesn't allow me to open that link because I'm logged in from my org organization laptop. Is there a way, how is this link be available
Check
from
this
access
VA.
standpoint?
Just check using another link, this one, va.landing.ai. And let me know if that works.
I
va
doubt
dot.
even if that will work. I know this session is getting recorded. Like, if I have to access it later, would the link or the tokens work?
Uh, I think because of your org restrictions, I'm not sure if later
No,
they'll
I'll
work.
try it from my
Oh,
I
I
was
see.
planning to try it from my personal laptop once I reach home, but
Yeah, it
that will
will
be
work. Yes.
in next 4 hours or something like that. So,
Yeah,
do you
it will
think?
work.
Okay, cool. Thank you.
Yes, for this session, I think you will have to listen along if you cannot try. But yeah, I'll be showing everything, so you should be able to follow along. I cannot think of any other way, can we? I think if I give you an API key, but how would I give you?
That's
Can you
fine,
open?
Ankit. That's
Yeah.
fine. I don't want to hold the whole class just for that. So we can keep going. I can do that later. Uh, that's fine.
Okay.
Thanks.
Okay. Or just give me just if you have an email, just give me the email on the chat, and I think I can send you something that will enable you to run the notebooks that I'll have for you. Okay, let's get back to the sign up. So you should see something like this. If you're in US, then this should work. Otherwise, you have to switch to EU. And then you click on continue with Google, or you click on create account, right? Put your email. Like this, something like this. Here, create account, CAPTCHA, right? And then check your email. Let's see if I got something. I did. 157. Now it's asking me to set a password. Let me set something funny. My name is something something. Okay. Financial services. Let's just say workshop. Let's start. Org name. My initials maybe. Create org. And we are in with 1,000 credits at our disposal, right? So you guys should be here with me. Okay, so type in the chat, whoever is in, just say in. Awesome. So nice to see all these floating ins coming in. Okay, anybody stuck? Just type stuck. Okay, nobody's stuck, I believe then. I don't see any single stuck here. Awesome. Great feeling to see that. Okay. See, this is an important step, so I'm just taking my time. Otherwise, I got Nikhil's email as well. Nikhil, during the session, I'll email you, right? I'll just unshare my screen for a second and then I'll email you, okay? So stay tuned for that. For everybody else, I will get you all started right away, okay? Okay, so let's go.
So I see Bhavna raising hands. So does Bhavna have a question?
Yeah, Bhavna, go ahead if you have anything. Oh no, sorry. Okay, let me. Is there? Hey, moderators, just put her hand down. I think I cannot do it. Otherwise, I would have said that. Okay, let's start. Uh, okay. Now the next thing you guys need to do is now you have created the account. Go to the Google Drive link. I'll paste it in the chat again. Not again. First time. Sorry. So the second most important step is to get access to this Google Drive. Let me know if it's accessible. It should be. Okay. Yes. Okay. Nice. This is the second most important step because all the resources that we are going to be using are here in this Google Drive. Okay. How did I go there? Nothing. Just I pasted the link and it opens in the browser. Okay. Cool. So this has the notebooks, the Jupyter notebooks. There are 3. The whole end-to-end demo for the whole pipeline, parse and extract. We have a comparison notebook, which is very amazing. You'll love it, I guess, when we come to not, you will definitely love it. I'm not guessing because this is something I've seen people being very interested in. Okay. And then the third one is the custom prompt demo. I think that's also a cool feature, the custom prompt, where, let's say you have a figure or in your document, then you can like write some custom prompt and extract the caption from corresponding to that figure. So we'll explore that too. No access to Google Drive from my office laptop. Seems like this will be a blocker for me today. Yeah, Nikhil, I think yes. Then in that case, even if I send you the API key, it will be a blocker. But no worries. Yeah, later when you go to your home, you will be able to do all this, and there will be recording as well sent to you. So nothing to worry there. And the
Yeah,
free
if you can send me the link in the email, that will be great. All the links there, because I don't know if the Q&A is persisted in the, like, when you look at the recording. So it'll
Yeah,
make my
I'll
job
do it.
easy to copy and
Yeah,
start
I'll
using
send
it.
that. No worries, Nikhil. I'll send right now. Yeah.
Appreciate it, Eva.
So 3 notebooks, right? And then all the necessary input PDF or image files that are included here, okay? And yeah, last but not the least, the slides, because people love slides. And I have like more than 40 of them, I believe, because I know people love slides. So I've put a bunch of them. Okay. So these are the slides. This one is incomplete because you don't really need it, but yeah. So we're gonna go through all this, so it's fine. But for all the others, you have all the slides here in the form of a single PDF, okay? Okay, now you know what's in this drive. Let's go ahead with our very first demo. You guys might be thinking, oh, what just happened? He didn't even introduce himself and now he's opening the notebook. But yeah, just bear with me and let's do that. It's gonna be fun. So let's open this one. Custom prompt demo notebook. See, this is gonna be a problem, right? Because it's opening like this, which is not what you want, right? So what you want to do is open it in Colab. I see. So it's incognito and not signed in. That's why it's opening like this, right? But if you go in your logged in Google Drive, and then you open, which one? The custom prompt one. You will see something like this. It will go to Colab. Okay, type in if you're here in the Colab notebook with me. Okay, I see one no from Raj. Raj, what is it that you're facing? See, there's open with, and then you can choose Google Colab, right? So if it automatically doesn't go to Google Colab for you for some reason, what you can do is click on these three dots, click on open with, and then select Google Colab. It's a free tool provided by Google generously. Bhavna, you don't need it.
I'm so
Who was it? Was it Bhavna?
sorry for bypassing the raise hand. The Colab notebook, is that my drive?
So it's not a tool that you need to download locally. It's something that will live on your browser, right? By default, it will be accessible, should be available to you. So when you click here on the three dots and click on open with, do you see this option or not? That's my question to you, Gabriella.
I've got the whole drop down list, right, of documents and stuff, but I want to get to where you are. So I've
Okay,
got the
so
custom prompts, the LLM. So which one is that?
custom prompts. You need to click
Custom
on
prompts.
custom prompts, right click, and then open with, and then Google Colab.
Yeah, at least on. So I'm Bhavna here. On my Mac,
Yeah.
I don't see the Google Colab by default.
Okay.
I was wondering if there's some other way.
It
Click
needs to be
like this.
downloaded from Google
Yeah.
as an extension to your
If
browser.
you've never
It's
used it,
free.
then yeah.
Yeah, okay.
So you don't use it locally, just go to this Google Colab, type it in your Google search bar, and then go here and then sign in to it using the same account that you might have used for your whole Google thing and AD,
Okay.
right? Okay.
Sorry, Ankit, is it the custom prompt demo or the comparison?
Custom prompt, yes. We're gonna start with custom prompt demo because it's a good way to, get acquainted with the parse feature of Agentic Document Extraction. Gabrielle, are you there now?
I've opened it in another tab and it's like the browser is circling, so I'm hoping it will get my internet will open it.
Okay. I think it will. Just hold on a little and I think it will. Okay, let's go for others. Let's just proceed with this. Just do one thing now. You already have an AD account, right? You have signed up, right? Just click here on the API key and it should redirect. So in this notice, just click here on the first link.
Repeat it, please. What did you say?
Yeah. What were you saying?
Can you repeat this? What were the
Yeah.
instructions?
See, in the custom prompt demo, click on API key here in the prerequisites. And then it will go to this. And then click on this link. It will take you to your API key.
So I'm in the Google Drive. So where is supposed to go? I'm in the Google Drive.
Okay, for Google Drive, you have to open this notebook, custom prompt, in the Colab.
I don't have that option.
The Colab?
Yeah.
Okay, and when you paste this link in another tab, does it open Colab or not?
Okay, let me check.
See, the link is in the chat.
Yeah, you got it.
Does it open?
Yeah, that opened. Welcome to Colab. Yep.
Do you see this notebook?
So what, you have to open a new notebook? So I got the open notebook. Now says no. How do you open that specific file?
Yeah,
Go to Google Drive.
I'm stuck on that same step. So
I see.
yeah, open notebook and then how do I
Hi, if
use
I
that notebook link?
directory here, like when you're in your drive and when you right click and go with open with, you will find connect more apps. So you can go there and search for Colab and then connect your account and then it'll automatically open after that.
True, yeah. Otherwise, just download and upload. Which means from your Google Drive, you download this and then you upload in your Google Colab using this feature.
Okay.
Okay.
Download and upload. Okay. So
that's another way if you're not able to connect to Google Drive directly. Okay. So now.
Okay, finally. Yeah, able to open it.
Oh, nice. So now when you have it open, you'll click on API key. It will take you to this link. And then you click here and you'll see the API key and you'll copy it. Another thing you can do is directly open this link that Ava has sent in the chat.
Yeah, please.
Right? And then you will see this key. Because you have already signed in, you have the credits.
But you need to create your own key. I see in the questions that do they see the key? No, you need to create your own because this key is exclusive. Like other people cannot see it. You have to create your own for your own project.
Yes. So I closed the incognito otherwise. Yeah. So what you need to do is create your own. And then copy it. Okay.
Okay.
And then finally, you come here in your Colab, click on the key, the secrets.
Can you explain more about how to create a key? Like, can you show, for example, create a new one for the Data Dojo? Because like there are more questions about how to create a key in the conversation. Yeah, thanks.
Okay, let's do it again. Oh, CAPTCHA. Okay, motorcycles.
So the docs link is a step-by-step guide. You're supposed to follow the docs. So you need to go to the va.landing.home to create a key. So the docs is just a manual, a guide, like telling you how to create a key. Yeah, but to be ordered to create a key, you need to go here.
Okay, so you see my screen, there's a create key, right? Just click here, name your key, anything. Like, I don't know, workshop, right? And then create. And then copy, then done. Is it? Yeah. Okay, so I think you all should have the key right now, okay? Let me know if anybody has a problem in getting the key. Okay, so let's move on back to the notebook. So what you will do once you have copied the key, you will come here on the Colab, click on this key, and then paste here your key. Click on add new secret, right? Paste your key. And then for the name, you copy this and paste here like this in the name. Okay? So your value is your key. Your name is this name, Vision Agent API key. And then you click here and grant this notebook the access. Okay? You don't need Open Router for this notebook, just Vision Agent API key is what you need. Okay? Okay, I'll delete because I already have this set up, but let me know if anything is unclear.
Can you do it one more time?
Yeah.
I created the
I'll click
key.
on this and I'll add here a new secret. I'll paste my key and then I'll paste this name, Vision Agent API key copy from here.
So you can put any name, right? Only value
No.
column you have to put.
Only this name because it's internal to our code, which means
Right.
our variable name has to be this. That's how the SDK is set. So this name will be identified by the code that I've written here. Okay. So you have the value here, which is your key. You have the name here, which is this. And then you will enable access here. Okay. Okay, cool. Okay, now all the setup is almost done. What we will do is run this code. Okay. So do one thing now. Click on runtime and run all. It's gonna run all the cells. See, it's running. Now what it's doing is using the DPT-2 latest model for parsing the image. So here's a flowchart. If you go back to Google Drive, you have this sample one. This is the flowchart. So it's using this image and parsing it. See this image? That's what is getting parsed using this model. LandingAI's document pre-trained transformer to latest model. Okay, which supports this feature called custom prompts. And then we are going to provide some custom prompts and caption this image. Okay. Okay. So see, this URL is set here in this parameter. This parameter is the document URL. That document URL goes into the system. See here in the parse method of the client. And the model is GPT-2, which is initialized here, right? And then your output comes via printing. Okay. And then this is the output you see with default, with the default, without any special prompt.
Hi, sorry to interrupt. Could you repeat that again, please? Like
Yeah.
from the running the notebook part.
From like the point where I set the API key and I'm running the code.
Uh-huh.
So you click here on the runtime and click on run all, right? So what happens is all the cells start running step one by one from top to bottom. As you can see, I have everything run here. All the outputs are here, right? And then what I'm doing is just explaining the codes and their outputs so that you understand actually what is happening, right? So now that you have run this, I think you should all be able to see the similar outputs that I have. So now do one thing, like look at the image. What you can do is go back to your Google Drive and open the sample one image. And then on the other Google Colab tab, what you can do is see these outputs, right? And then you will notice something cool, which is how when we are changing the prompt, like here, if the image is a chart, format the data as a HTML table with column, header, and values. If not chart, then describe concisely. So how does it know whether it's a chart or not, right? So what it does is it's like every chunk, so the parser understands the chunk type. So later we will see these chunk types in another notebook. So there are chunk types like text chunk, figure chunk, table chunk. So depending upon the PDF, the kind of elements within the PDF, right, your chunks will be categorized as one, right? And then depending upon that, if it's a chart, it will do that. If not, then it will not, right? So if it's a figure, it will do that. If not, then it will not. So it captions according to what the chunk type is. So basically what you're getting is a feel of how like custom prompts work, right? Like, so how you can quickly have your charts or some sort of figure or image, right, analyzed. Okay. So you can think of like a variety of use cases of this, right? Like you can have a RAG optimized detailed description where you can have a specific format for your chart, right? And then you can feed it.
Can
Yeah.
you quickly explain what chunks mean? Maybe show it in the playground. Like quickly, like
Yeah.
intuitively what chunks mean. We see one question.
Yeah, that's a
Eamon.
good question. Yeah. So let's do this. See this. I have it open. Like this is some PDF. This is a table chunk. See, but this image only has tables, so there's no other chunk. But what I can do is show you some more chunks. Like let's say this one. See, this is text. This is marginalia. This is table, right? Text, table, marginalia again. So this is what I meant by chunk.
Thank you, Ankit. Excuse me, I took the micro because it was my question. This is Imen from France. So I was wondering what so you can design some chunks as chart or as table, and especially the chart from the clinical study that I was seeing in the sample number one. that means that you know the type of document somehow, actually, because a chart in a clinical study is not a chart in another type of document. So how do you define this? Is there any ontology behind your model or something?
Mm-hmm. So if you go to the docs, see here, this is icon for docs. What you can do is search here, ontology. And then you'll see chunk types, text, table, figure, logo, card, decision. So these are the definitions. But now if you're asking me internally, how do you figure this out, that this is a text, this is a table, this chunk is a figure, it's a logo, right? So that's a lot of internal code that we have written in it's like think of it like a classification model that classifies these chunks into specific types, right? So it's a machine learning model that you can train to classify these different chunks or segments within a PDF or image into these kinds or categories,
Okay.
right?
Yeah.
Okay. Okay. See, this is the advantage. Like I didn't share anything, and now you guys are like pumping all these questions. Your brain is like jogging with, okay, what is this? What is that? And I think that's one part of the learning where you don't know anything, but you still figure out a lot of things, and then the remaining gets answered. Okay, but what I wanted to do is to quickly get the setup done and show you the Parse API, explain a very nice use case of custom prompting and analyzing the figure type chunk using custom prompting, and then showing you how, depending upon the prompt, your output can change. So downstream, you can have a variety of use cases, right? Like, so I've written them already here, like what kind of use cases you can solve with this feature, right? Like your RAG pipelines, make charts searchable, your table to chart conversion, your multilingual document processing, accessibility options, token optimization for downstream cost reduction, domain specific context you can provide, right? So yeah, you can think about it later, but for now, what I wanted you to know is, first, I wanted you to come up to speed with the setup, and second is I wanted you to see a very quick introduction to the parse, right? Okay, now forget about everything and let's go back to the basics. So let me get back to my slides. So you know where the notebooks are. You have created an account. This is the playground that I've already shown you via landing.ai, right? You have seen the chunks, some images in that playground, right? You already are seeing my slides. Yeah, these are the previous workshop links for later. If let's say you feel very interested after this workshop and you want to go to the previous ones and watch the recording, this is where it is, okay? Okay, so now let's go back to my introduction. So currently I'm developer relations specialist at LandingAI. My LinkedIn shows GTM lead as well because I've been handling a lot of go-to-market stuff at Landing besides developer relations. That's why that title. But yeah, I've been primarily busy with developer relations, building very, very contextual functions in different kinds of startups, mostly startups, right? And yeah, so that's what I've been doing since the last 5 years, developer relations, which means bridging the gap between the technology and the developers that use it, okay? Through different things like this kind of a workshop, tutorials, live streaming, coding at some like Twitch or YouTube live stream or something, or I don't know, writing a tutorial, going to a conference. So these kind of things I've been doing a lot since the last 4 or 5 years. Before that, I was a researcher. I invested a lot of time at the intersection of natural language processing and computer vision, and then I did a lot of research on deep learning based image captioning architectures. But my initial beginning was as a full stack software engineer. I spent 2 years back in India from 2014 to 2016 before coming to USA for my master's in AI. And then after master's, I worked for 2 years as a researcher and then 5 years as a developer relations specialist. So that's something about me. Outside of all this, my professional life, I love philosophy. I love AI, exploring all these frontier models, and I'm getting into crypto since the last 2 years as well. So if anybody of you is passionate about crypto and trading, feel free to reach out. We can discuss. And I'm also a big fan of movies and adventure sports. So if you're in Bay Area, I'm always down to watch a new movie and do some sort of extreme sports. So yeah, feel free to ping me. Okay, so that's about me. Finally, yeah, Jane. Finally, my intro. Okay, so like the actions speak louder than words. So I just wanted to speak using the actions, like before even utter any word. But now that I've uttered some words about myself, let's go to some of the remaining agenda for today. So we have finished the intros, the sign up, and the quick start. Now we are gonna go back to the basics, which is get into the agentic document extraction building blocks and basics. And then we will quickly look into a benchmark. And then we will have some more advanced theoretical aspects about ADE. We'll discuss them briefly. And then we will run those notebooks and see some use cases if the time allows at the very end. Okay? Okay, so without wasting any time, let's just start with all this. I'll just quickly do a slideshow because that will allow you to see my slides better. Okay? Okay, so this is our latest launch. It just happened yesterday, Agentic Extract APIs. So once you saw the parse, right? So parsing is all about you give a big document and then you see a huge JSON that comes out, right? Or a markdown that comes out, right? So markdown is actually one part of the JSON. So in that JSON, you have a field called markdown, and that markdown is a markdown representation of the whole document that you feed in. And that markdown can be later inserted into an LLM downstream so that you can help LLM understand your document better. Now you might be thinking, why don't I just put my PDF directly into the LLM, right? That answer you will get when we go through the notebook LLM versus AD very, very clearly and precisely. Okay, so wait for that. But yeah, for now, just understand that LLMs cannot really struggle with parsing a lot of complex layouts and images and PDFs with a lot of tricky, messy scan docs, handwriting elements, and complicated layouts with complicated merged cells, padded headers and stuff. So that's where ADE shines. ADE stands for Agentic Document Extraction, by the way. So whenever I say ADE, just understand that I mean Agentic Document Extraction, okay? Okay, so what happens is after the parse, you get this huge JSON output of everything from the document. But let's say you're not interested in everything. You just want some specific 2 or 3 fields. Then that's where you can have this extract API. And for folks who are deeply acquainted with IDP and OCR, imagine millions of documents, right? And then you can have thousands of fields in those millions of pages, right? Or you might have a huge invoice and there are millions of invoices and there are some specific fields like invoice ID, invoice description, and you want only those specific fields from all those different invoices to be extracted. So this is where this extract API comes in handy. Okay. Okay, why document automation breaks? It's a bunch of theory here, like 90% of enterprise is unstructured. You might have heard this on and on, right? Like structured, unstructured to structured. I don't want to bore you with all this, but yeah, read these slides if later you would like to. Enterprise data is locked inside documents. As you know, documents form an integral part of different modalities that you see in the real world, right? Still, you have a lot of things in your manual scans, and maybe it has digital origination where the PDF is digital, but still it's very complicated for traditional OCR or LLM to parse, and that's where a product like ADE succeeds because it's built for these scenarios that are tricky and complex, and we will see what scenarios these exactly are, so stay tuned. Okay, so this is a bunch of theory, but I would just go through some of the really important and interesting parts. For example, vision first, agentic architecture, right? So the differentiation that we have with agentic document extraction is in its vision first approach. Okay, so what happens is in your LLMs, even if it's a natively multimodal large language model, which means that it's trained on not just text data, but also image data, the problem is they have a hard time associating text and images together, having like inferring contextual relationships between between the text elements and the images in a single doc, really understanding the spatial coordinates of these different images in the document, right? So spatial localization is a big problem that LLMs face regularly, and complicated layouts, things like very large tables, handwriting, and low resolution scan documents are really challenging for these LLMs and OCR models. And that's where we will see how a vision first approach is very beneficial, which means like this shortcoming comes from the fact that the LLMs struggle with understanding spatial arrangement within an image, and understanding the contextual relationships between different elements, like let's say text, let's say image, let's say flowchart, let's say some sort of like logo, right? So they're contextual associations. So these are the things that LLMs and traditional OCRs and parsers have hard time understanding. And that's where the vision first approach of ADE, which means like looking at all these documents as like visual representations of information, not just text blobs, is what helps. So what we have done is our entire philosophy, the paradigm of ADE, relies on vision first, which means we treat all these documents as visual entities. And what we do is train specialized models for different you saw these different chunk types, right? We train different specialized vision models that deals with different types of chunks and understanding them. And then ultimately the agentic nature, which means this agentic architecture, what it enables you to do is associate agentically. Like it goes on reasoning about all these different chunk types, and it starts thinking about how they're associated with each other. And then it does some back and forth to finally come up with the most accurate parse representation that you already saw as an output, right? So that's the high level architecture. So in the previous workshop that we had, I think 6 to 8 months before with Data Science Dojo, I go very much deep into how transformers are autoregressive, how agentic capabilities are scaffolding, which means when you might have used Claude Code, you see like a bunch of tools, like 18 tools used, 9 tools used, right? So that's what I mean by agentic capabilities that are as scaffolding. So those tools actually are what brings this magical effect of like PDFs getting comprehended, right? So it's not just transformers that is being leveraged, it's a lot of other tools like PyPDF, this parser, that parser, that these coding agents leverage when they're analyzing your PDFs that you upload, right? But even then, after all those 18 tools or whatsoever, they really struggle with a lot of complex layouts that we're gonna discuss shortly, right? So in that workshop, I go really deep into like how like language have strong priors, how like vision is a continuous modality with weak priors, and how that's where these LLMs struggle with the spatial reasoning, especially when the priors and the vision modality are so weak. So if you're interested, like definitely go through that workshop and you will have a deeper understanding of why these LLMs struggle. Okay, so this is all from the previous one. Okay, let's just quickly understand 3 major aspects of agentic document extraction, right? One I already explained very in a lot of detail, which is vision first approach, right? Right. Second one is data-centric. So data-centric approach or data-centric AI means so think about it. Now you have these weaknesses or like spatial localization, spatial reasoning where these LLMs struggle, right? So what do you need? You need specialized vision models. So how would you train these specialized vision models? You need data for that, right? So where does this data come from? So you would have to curate these data, right, from somewhere. And then when you curate this data, that's where data-centric practices kick in, which means how do you curate that data? You have to follow some disciplined engineering practices where you really curate a diverse data set, which has all those different layouts where you are struggling, where your LLMs and traditional OCRs and other parsers are struggling, right? So that is what I meant by data-centric practices, where you really like systematically curate your data sets, considering the diversity in layouts and all the telemetry, right? So that's what I mean. Like you have to establish systematic data-centric practices, which are focused on incremental continuous improvement, so that you have some sort of feedback loop, right? Like, okay, this is where the model is struggling. So these are the kinds of documents in the financial services industry or healthcare or legal or whatever, and then add more documents in that category in your curated data set, and then retrain your system, right? So that's what I meant by data-centric practices. So you have to, so just for your knowledge, like I'm trying to make you understand like how, if you want to develop these systems on your own, how you would think about it, right? Okay, so now you understand Visual First AI, now you understand data-centric practices. Now the final part, the third thing in the paradigm, it's agentic by design. So we discussed this briefly already, right? Like how, when you have these models, there's some sort of agentic orchestration, right? Like, for example, somebody asked me, hey, you have these chunk types. How are they identified? So I told you how there's a classifier that classifies them, right? So there's a classifier. There are some specialized domain-specific vision models, right? And then there's your LLMs. Your LLMs might be captioning some images. So you have specialized vision models, then you might be using LLMs. Then you have a classifier that is classifying different chunks, and then you might want an LLM to operate on one chunk type. You want a specialized vision model to operate on another chunk type, right? So then how would you orchestrate all this? That's where this agentic by design thing comes in, right? So this is all agentically orchestrated so that the final quality threshold passes some sort of level, like maybe 95%. That's what you want, right? So that's what you mean by agentic by design. Okay, so this is the paradigm: visual AI, data-centric, and agentic. So together, these three things combined together forms the basis or the guiding principle behind agentic document extraction. And that's what is so powerful towards a product or offering like this. Okay, so these are some of the features, like zero shot on all document types, no training or fine tuning required, visually grounded outputs. You kind of already know that, right? So you already saw that those chunks were bounded by boxes. That is what we call visual grounding, which means that you know the place where you found that exact text or the exact value within a table, right? So that's what is meant by visually grounded. Zero shot means you saw the parser spilling out all its output in one go, which means like we didn't do any sort of training or fine tuning, right? We just put in the PDF and then it just gives you the output right out of the box, right? That's what is meant by zero shot. Schema driven and JSON ready for production. Yeah, we will see the schema driven thing later. Don't worry about it. But I explained to you that there's a new launch, which is ADE extraction APIs, right? And that schema is something that we will use. Okay, one last thing, it's built for developers, which means that you have these APIs. The product is offered as RESTful APIs, and also you have Python and TypeScript SDK, which you can leverage. So downstream, you can build using these libraries for your document processing automation needs, okay? Okay, before going into the demo, let's just quickly discuss about this benchmark, because it's a very important question that will come in your mind again and again, that, hey, how accurate this is, right? Is there a quantitative measurement behind the accuracy to justify this? So that's where this question will be answered. So if you go here, there's a blog that goes into the detail. Everything is transparent and reproducible, which means that if you want, you can like reproduce all these results on your own. Okay. So we took a validation split from the doc wiki and a data set, and then we noticed that out of all these questions, so there's like a bunch of images, I think 2000 or something. And then out of those 2000, you have like 5,086 questions that are asked on those images. And then the AD got this much right and some wrong, right? Okay. So that's the accuracy part. Okay. So yeah, dig deep into this if you would like later. All the failure and success instances are here for your at your disposal for the utmost transparency, right? So it will show you the document, all the details, all the metadata and everything. So go in the gallery and you will be able to visualize all of that. Okay, back to the slides. I think already 1 hour is done, so we need to like buckle up a little. So I'll be a little fast, okay? Okay, back to the slideshow. Okay, so right now, if you think about APIs, there are 3 offerings. There are 3 APIs: parse, split, and extract. We're not going to focus much on split today, but we'll focus excessively on parse and extract. So you already saw parse in action. You will see extract as well in one of the notebooks that we'll run. Okay. So we talked about proprietary models, right? Specialized vision models. So there's something called agentic table captioning, which means like you have a large table and LLM struggle in reproducing these large tables as CSVs or whatever format you would like at the end, right? So which means like, think of like, I don't know, millions of cells in a table and different complexities like merged headers, different spans in those headers, right? So we'll see a bunch of these in our notebook when we compare ADE with LLMs. But for now, just imagine something like that. And then if you would want to extract all those values systematically without error, then that's where your LLMs will struggle really bad. So that's what it means. Like agentic table captioning is what is facilitated in ADE, right? You already saw expanded chunk ontology. You have seen the layout detection in action with Parse. Refined figure captioning, we have already seen in the custom prompting, the figure captioning part. So now you see, right? Like before you come to the slides, you already know like all this, right? That's the beauty of sometimes going in the reverse order. You can associate all this theory. Okay, I think let's just quickly go over this one. This is interesting. Infinite schema, master schema, but these are the advanced things. Like for extraction, when you're only interested in specific fields instead of the whole extracted output, then as I said, you need extract API. And in this API, there's a capability we call infinite schema, which means like, let's say you have 5 invoice documents with slightly different layouts, you can just put them in and it will create an exhaustive schema corresponding to all those 5 invoices, something that I'll show you later. So infinite schema is like, in those schema, you can have like really complicated nested fields, right? So you can have like name, address. In the address, you can have another level of nesting with like, okay, address, which address, what is the zip code, right? Area code, your locality, this and that, right? So you can have like a lot of nesting, like 10 plus levels of depth in that nesting. So that's what we mean by infinite schema. Master schema, which means like, as I said, 5 documents uploaded with slightly different formats, it will automatically intelligently identify a master common schema so that you don't have to build different schemas for different documents. If you are thinking, why do we even need a schema during extract? It's because, think of it, right? Like you need a specific format. Like you need, let's say 5 fields out of thousands. But how do you need these fields? There might be date. You need MMDDYY or DDMMYY, right? So you need a specific format for consistency. So schema is where you specify that format. So that's why you need schema, okay? Where you specify the format and then you extract according to that format. Okay, let's quickly go. AD is offered in the cloud and as VPC. It's not that interesting, but for enterprise folks, it will be interesting, right? And the real world is enterprises mostly. So for them, obviously, this is something I had to keep in the slide and I did. But later in the Q&A section, let me know if you have any specific questions for these things. Okay, I think let's go to the demo part, which is the most interesting part. Enough of theory. Okay, I'll just quickly jump into the chat. I think Eva has answered most of the questions, but Eva, is there anything I should address before we move on to the notebooks?
So I think Nikhil has one interesting question. Can you address that? So what agentic framework you use at Landing, like LangGraph. Can you share your experience challenges faced during creating production-ready agentic apps for Document AI?
Is this question in the chat somewhere? Can you type it
Yeah,
again?
in the chat. Nikhil's question. Yeah, I'm
Okay,
gonna
is it
copy it.
recent? Let me just see.
Yeah, it's the bottom three.
Can
And
we run high
also,
algorithms, Raj?
and also, like Eric's question is quite interesting. So, is this like a digital twin problem for like a computer vision? Just
No, it's
it's
not. Yeah,
yeah,
digital
Can you
twin
address both? Yeah,
is
can you
not.
address both, like
Mhm.
Nikhil and Eric's question?
Yeah, so for digital twin, that's not, Eric, that's not what we're doing. It's not a, actually, it's a very interesting way to think. I can see why you would think like that because in your mind, you're thinking that, okay, we have a document. Are we creating a digital twin of that document? No, it's not. Think of it like we're not creating another image. It's not image generation by any means, okay? What we are doing is, see, the highlight of the benchmarking that I showed you on Doc VQ&A is even if you don't show AD, even if you don't show the LLM, let's say you have the whole parsed output and you feed that parsed output into any LLM and ask it any question about the PDF or the image, it will answer because now it has all the context from the parsed output. So without even feeding the original image, only the parsed output, if you feed it into the LLM, it will be able to answer all the questions. Why? Because the markdown, the parsed output, has such a rich representation of the document itself that you don't need the original document to begin with, right? So I would not call it a digital twin, but it's like holistic output that we aim to produce, which is accurate and holistic, which means it's so comprehensive that it doesn't really leave anything out of the image or PDF. Okay. The second one is agentic framework you use at LandingAI, like LangGraph, etc. Can you share? That's an interesting question. There's no name for it. Like we have studied, so before we introduced ADE to this world, our focus was a lot of different things, including something called Vision Agent. So in Vision Agent, it used to, so that was an agent that produced computer vision code. So if you give it some problem and a video or a file or image file, and you ask it to solve it, it will write the code that, like computer vision code that you can use to solve it, right? So in that, we did have a lot of agentic frameworks uh, that we played with as the architectural component of the vision agent, right? So you can read about it. I can send you some blogs later, but the bottom line is we learned a lot from from all those years of experimenting with agentic frameworks, and then finally came up with some sort of architecture or framework for the agentic orchestration part. So that's the best answer. Since it's a proprietary mechanism, I cannot just, and even if, let's say it was open source, I would have asked you to just look at the code because there's no specific keyword, right? It's custom, right? So yeah, that's the answer. I hope that helps
Yeah,
get
I
the
mean,
answer.
more of the question was, thanks, appreciate that helps, Ankit, but I just wanted to understand when you productionize such agents, how do you do eval? How have you used any LLM as judge and making sure like, the accuracy is on point, monitoring, etc. That was like, and also scale part, right? If you can shed some light on that, that'll be.
Yeah, so this is why I showed the doc VQ&A. See, the thing with doc VQ&A is we don't the benchmark just asks question from those images, and then you're expected to give the right answer, and you get a 1 point if you're right, if you get 0 points if you're wrong, and that's how the accuracy is calculated. So that gives you a good idea because if you see the kind of documents and the kind of questions, they're really tricky for even a human sometimes to answer, and that's why it's kind of a good approach to really feed the markdown parsed output to an LLM and have these questions answered to evaluate how good that parse representation is for different documents. I think that's a good test of the strength of parsing. But if you look at like edit distance metric, I don't know, some sort of WER, CER, that's not that intuitive and accurate, because then the spaces, the special characters, there are so many things to consider, and a slight variation in all those will actually hamper the metric output quantitative score. So this is where, when it's like a mission critical scenario where everything matters, what these enterprises do is they write their own evals, right? So they will do smell tests, which is nothing but they will like look at the output results of the most complicated documents. They will eyeball those output results, and then they will see where all the other models fail. Is it succeeding? And if they do, if it does, then they start going deeper into, okay, now it has succeeded in the most complicated subset of documents we have. Let's dig deeper and see if we can actually put it into production. And then they start writing evals. They generally have evals to begin with, but then they sometimes cater them to the output, that the format that the parsed output has, right? And then they start evaluating it. So that's the answer I can give you on how I have seen people doing it practically. Like no like BS of benchmarks and dog bench, this bench, that bench, and like twisting the outputs according to your own model, or just showing only the elements where you were right and other models were wrong, right? So this is where, yeah, that's what I can say. Okay, let's go to the demo part. Let me share my screen again. Can you guys see my screen?
Yep.
Okay. So what you're gonna do is go back to the drive. Sorry, my teeth. So this is the Google Drive, the same one. I'm gonna put it in chat again. Okay, let's quickly do AD versus LLM before we go for the end-to-end pipeline. I think that is interesting. I'm changing the sequence. I originally thought I'll do the pipeline first, but now I want to do this first. So we are going for AD versus LLM. Open it again in Colab. You already have everything set, the secret as well as the, oh, so there's one problem here. The open router API key, which means you don't have this API key. So what I'm doing is using Claude and Gemini through open router. So I have like some money in my open router account. Here, see. And then what I'm doing is leveraging that to route to these LLMs and then comparing with AD. Since you don't have the money and all that, you won't be able to run this. But later what you can do is feed in like $2 or something and then check this. But let me just quickly show you what you can do later, right? So same here. Just go put your open router key and just name it, copy paste this name here, enable again the access, and then start running. Click on run all. Okay. So, but for demonstration purpose, let's just take one or two examples and compare. So it's running. Here, what we're doing is just doing the initialization and setup, right? I'm just putting some chunk colors out because in the playground, all that is automatically done for you, right? But here we have to write code to do all that. So what we're doing is initializing all that, like what chunk color for what. And then setup complete. So this is run. I'm going to upload one document. It's asking me to choose files. So I'll go and choose a file. What I'll do is choose table2.png. This is a complicated scan table. Open. It's uploading. Ready. These are some helper scripts. Okay, now this is the prompt. Parse this document into structure, mark down requirements, preserve all text exactly as it appears, convert tables into HTML, blah, blah, blah. And now let's parse. Claude Sonnet 4.5, and then it'll call Gemini. Let's see what it does. I was playing with this. It was the last moment change. Like right 1 hour before this workshop, I was like, okay, let's just spin up Claude Code and write this and then see what happens. Because I thought it will be very interesting to compare. Okay, it's running. 28 seconds. These many characters came from Claude Sonnet. Now it's running Gemini 2.5 Flash. Light. These many characters. Now it's running ADE Parse. Okay, look at the complexity of the document. It's a synthetic document that I've generated specifically. See, there's some sort of code, there's some sort of item description, there's quantity, there's original ORIG code, then there's IVA number, there's currency, net amount, and a bunch of other things. Then you see how like the complexity is there. Like this NP, yeah. I think you get the idea, right? Real world documents are like complex like this. This is what I was talking about earlier, right? Now you get a good, I think, sense of what I was talking, like merged cells, span across cells, this and that, spacing issues, no neat and clean lines of separation. Okay, it's run. Now I will run this one. The document is here. Visual grounding, I already told you this is the chunk ontology. This is the visual grounding. Since there's only one table, it's table chunk, right? Now what I'm doing is dynamically generating a bunch of questions so to ask and then compare. So what happens is based on the discrepancies in the output or the differences in the output, it kind of generates 5 questions. And then we will, okay, it did generate 5 comparison questions. Then we will side by side compare them. Oops. See, this is missing. Okay, so Claude Sonnet says this all matches 1.05, 1.1. Let's see what one is correct. IVA rate value for the item LMN01. So here's the value. IVA 1.05. So I think AD is wrong there. Nope. Yeah, it is wrong. So 1.05. Let's just quickly check. Yeah. See, actually, this is where everything is wrong because, wait, because the IVA is this. It's not this. So we have everything wrong. Okay, let's see others. Peso, credit peso, 4WX.
Can you maybe like close the secrets on the left and maybe have the image to the left? Yeah, thank you.
Okay, W, where was it? Here. Man, is it even a bad representation? Where is the... Let me just check where it's like asking all the crazy questions. Payment appears in the net unit price for WXY. Payment, which is the payment column again? It's the currency, it's the quantity. This is the net amount. So WX here is this much. It's peso, it's credit, it's peso, and then because in the code it's not printed. The markdown is not printed. I was checking if the so WX, as you see here, it's again all wrong. See, peso is wrong, credit is wrong. The thing that is right is what? It's a number. And it's missing. I'm pretty sure it's not missing. It's my code that is wrong somewhere. Okay, so the problem I think is when I'm putting the AD parse, when I'm analyzing it, I'm probably outputting either the truncated value or the HTML representation, because of which it's not able to fetch. Because what happens is the ADE, like, okay, let's do one thing. For the ease, we can upload this document here. Table 2, right? And parse and see what happens. But yeah, you got the idea, right? Like, see how LLMs are getting confused too? Like, nobody is able to answer. Even when Gemini is like a natively multimodal model, which has image understanding and spatial reasoning ability, it's still struggling.
Actually, this morning I was listening to Lex Friedman's podcast, the episode about AI since 2026, and they were discussing like how like AI, the LLMs, they have gotten so much better with coding, but they're still struggling a lot with multimodality. So that's an area actually should be interesting to see how it progresses.
Okay, see here, folks. This is the one we were looking at. Classic, blah, blah, blah. And where's the W thing? So this is PX. Internal identifier. Oh, I see. So it's merged here. See, the problem comes is like it tries. So what the model is trying to do is see the separation, trying to understand the separation. It's like really complicated, right? Like if you see this, how would you separate these things? Even for a human, like it's hard. Like, do you associate NP with this? Do you associate this with that? We should actually take a better example. Let me just look into the drive what I have.
Okay, isn't the question regarding the currency and the payment type? So if peso and credit is appropriate there, I thought that was
Yeah,
the answer.
it's not.
Okay.
It should be the number, you're right. What about this? Let's just put this one and see what happens. Better table.
Excuse me. I'm sorry. I think the question was about the type of the payment. So credit for me was correct, and the peso was wrong.
Let's see, which was it? Currency or type appears in the net unit. Currency or payment type, right? So where is it? So you have Currency or payment type. Currency is here. So it has, and payment type is here. So W is credit, and then currency, it's this. So credit is the right if you are talking about the type, and then currency should come like this, right? So actually the question is confusing because it says oblique. So it's like confusing for an LLM also.
Right.
Because the question is wrong. Like, what are you oblique? What does this oblique mean? Or and? I think it's the question prompt that is confusing. Anyways, let's just take another example and see what happens. See if you this is what if you ask an LLM about this, like where these are, it won't be able to visually ground it. Because the way it sees this is very different from a human. Like you know that this cell lies here and you can pinpoint it, but LLM doesn't. See, this is the confidence score. Like the confidence for some reason is less here. That's why it's coming 57%. Anyways. Okay, so this is mostly right, as you can see. What you can do is just play with my code here in this notebook, upload this document, put some money in your open router if you would like, and see how these LLMs falter or not, and then how AD succeeds or not. And then I think that will be interesting for you to let me know later. See, there's errors. Like it's not like AD doesn't make mistake. It does. Here, see, it's 680, not 580. So anybody who tells you that, hey, we are 100% accurate, just run away. Just know that they're lying. So there's always some sort of like all the solutions in the market are definitely struggling somewhere, but it's just who is suitable for to the largest extent, and then how can we mitigate the consequences by having like some sort of feature like confidence score so that we can like look into the wrong values. Okay. So let's get into, and this is where all those concepts come in, right? Like the paradigm. Like, is the fault coming from you don't have these kind of layouts in your data set? You need to curate. So you should have like systematic data-centric practices so that you understand where is the problem coming from? Is it like you don't have a properly balanced curated data set? Or is it your vision specific visual model is struggling, some domain specific model is struggling, so you need to retrain that, or maybe your agent is not orchestrating properly. So you need to like have clear lines of demarcation because the signal to noise ratio is pretty hard if you don't have that clear line of demarcation in your technology, in your architecture when you're building these kind of technologies. So that's what I was trying to say, that when you're like putting these things in production, when you're like innovating, you need to be extremely clear on like how would you architect the system, what will be your principles, right? And then you have to act accordingly. Okay. Let's just do the final notebook, the end-to-end pipeline one, to really understand how the end-to-end parse and then extract API looks like. Okay, so go back to the Google Drive, and this time you will run with me because there's no open router needed, and you already have the AD credits. So what I'll do is paste this link again, the Google Drive, and then open the last notebook, which is pipeline demo dot. This one. End-to-end AD pipeline, parse, explore, extract. Okay. Are you guys with me? Open this. Do you have it? Just say yes in the chat and I'll proceed. Awesome. Okay, so there's a 24-pager loan document that we will upload here, right? This one. Where is it? Here, loan assessment. And then we'll extract a bunch of fields after parsing the whole thing. So we'll parse everything from this, and then we'll extract some particular fields by writing a schema. Okay? So you already have done all these prerequisite steps. Let's just run. So this is the LandingAI SDK, the Python one. So we have installed it. And all the prerequisites, Google Colab for the secret key here, right? And the other bunch of dependencies. Your PDF is kept in the Google Drive, and I already have the URL set so that you need not do anything. It's all set for you to play with, right? So run this. It's running. Parse the document. Setup is complete. It's parsing the document using the latest model. It's going to give out the pages, the number of the page count, the chunks, the credit usage, the duration, the model version. And then we'll save this to JSON so that later, if you want to extract something else, some other field that you need not parse again, you can just refer to the saved JSON, right? So you can save some bucks like that. So that's another advantage when you don't need the original document and you have this luxury of like saving the whole thing and then re-referring to it multiple times, millions of times, right? So that's how production systems work. It's taking some time because it's like a dense 24-pager. And yeah, and I think you all are running it. So it's like further increasing the load on the API. Okay, I'll just explain the code in the meantime when it's running, okay? So here is the chunk distribution, how many text chunks, marginalia chunks, table chunks, attestation, or other types of chunks, right? And then you'll see the grounding info. It's just to get a sense of like, what are the features of the API that you traditionally don't get with the LLM, right? Like these grounding features you never get, these classifications you never get. So it's like a hodgepodge in an LLM, and you can hope for the best. You have no visual grounding. You have no idea where it's coming from. You have to go and manually check back and forth, right? This is the preview of Markdown. This is the chunk info. Okay, so this is the schema part. This is going to be interesting. So there are different ways to generate a schema. What I've done here is given it a prompt, extract the project name, park name, estimate date, total estimated net cost of construction, summary table of the top level cost line items with their WBS code, description, and total. So very specific field extraction from some specific page of the document, which is 24-page document, right? And then I'm using the latest extract model with this prompt, and then sending it using the REST API. And then in 29 credits, I got all the information out in this format, right? So here we are not extracting fields. We are just generating the schema, right? So generally what happens is people who have these kind of loan assessment documents also have like specific requirements that, oh, okay, we will see these kind of fields to approve the loan or deny. So they already have a schema, right? So either they can upload their schema or they can auto-generate it. And then once it's auto-generated, they can see the whole exhaustive schema and then discard the fields that they're not interested in and only keep the ones they're interested in, right? So all this is you can do in this API. Okay. Let's see if that is run, and let's run other fields. The parse should be done right. Save to parse, so it's done. 24 pages, chunks these many, credits used, duration, model, GPT-2, save to parse. Okay, now let's run this. This is run. Now this is run. I'm just running one by one. Okay, now this one is running. This one is the schema building, auto-generate a schema with schema builder with build schema extract API. Okay, now it has given me the schema, right? So this alternate name is also an interesting thing that I'll explain later. So let's say I actually briefly alluded to it. So let's say you have an invoice, you have invoice number, another invoice, you have invoice ID, another invoice, you just have invoice. So it kind of, what you can do is set this and write here all those three names. And then the schema will automatically know that, hey, all these belongs to the same conceptual key in the schema. Okay. So that's where you can use this alternative names feature or capability. This is the manual schema. So what you can do is like have your own manual schema. This is just something that I've kept here for your reference. Then now this is the extraction step where you call the extract API, and then you use the schema, pass the schema, and then extract all the fields from the 24-pager document using the schema. So now it's extracting the fields. And then finally, there's this traceability cell. What it does is it finds out where that value came from in the original document, right? This is just a representation that I've kept for reference so that you know exactly what were the extracted values. This is a bonus item. You can run it in your spare time. So instead of like extraction using JSON, you can use Pydantic. For Python developers, it's something that is widely used format. Okay, so this is how your typical end-to-end extraction pipeline looks like. Everything starts from parse, and then from parse, you can build upon specific field extractions, and then you can use the parse. Once you have parsed, you can use it, I don't know, infinite times to extract as many fields as you would like. You can create your schema from scratch, or you can give it your own schema. You can use a prompt to create schema. So there are a bunch of options in there. Okay. So as you can see, the fields are extracted. Where are they? Here. This is extracted data, and all fields are extracted. We can run the grounding information, and it tells you exactly what the source chunk was. You can save these and then use as an overlay on your original image to use it as visual grounding, right? Okay. Okay. So that's it for this part of the demo. Let me quickly see if you guys have any questions before we proceed forward and cover a bunch of other interesting things about the API. Okay. Okay, so is there any question, Ava, that you think is interesting for us to take now before we
So
proceed?
Eric actually asked a very interesting question about, I'm not sure when you were talking about the response caching. I guess he asked like, how does this? I kind of lost the context about what this means, but he asked, how does this tie to an
Eric?
agent's memory and learning and recursive loops? If Eric, you can
Yeah, unmute Eric
reiterate
if you
it.
would like,
Yeah.
and let me know. Is he here? Where is he? Oh, no, Mike. Okay, no worries. How does this tie to an agent? To an agent memory and learning recursive loops. Tied to an agent memory. What ties to agent memory, Eric, exactly? Oh, I see what you mean. Oh, okay. Yeah, I see. Okay, so what happens is it's all internal, which means you get the ready-made thing. You don't have to do anything downstream for that, which means the moment the parse is called, there's a confidence threshold that needs to be met for everything that is parsed, right? From all these chunks. And if it's not meant, the agent internally goes about orchestrating internally different models and combinations of models. So there might be a combination of some written heuristics. So there might be some code. Then there might be some visual or domain specific model, right? Like an ML model, deep learning based model, a transformer based model for some sort of specialized vision understanding. And then there might be LLMs that are doing some of the reasoning. So internally, all these three things are orchestrated agentically. So you don't see that in action because the agent doesn't, like, for example, if you type something in Claude Code, it kind of does some processing, but you can expand to see what it's thinking, what websites it referred, what agentic search it performed, what tools it called, how those tools are interacting with each other and stuff, right? So this is not something that we have made visible where you can go and see, okay, what were the models that are orchestrated? Because people don't really care because they're not building these systems. What they want is abstract all that complexity and get the whole thing as accurate as possible. So internally, whatever the agent is orchestrating is none of their business. What they need is the highest amount of extraction accuracy as possible on their most complex documents. Right? So this is where, like, if you want to build such a system and you're interested in like, okay, how do I go about thinking when I build such a system? Then if you're asking from that perspective, then I've already explained, right? Then you have to see what kind of documents are simple for an OCR model, what kind of documents are simple for LLMs or complicated for LLMs, and then you have to find some patterns or where these complications are coming from, and then what are the elements. Then you have to have, as a machine learning engineer or scientist, the understanding of why LLMs might be struggling. And then once you have that understanding, then you have to solve those pain points by thinking of a way of like, how can you remediate those weak points by training some additional models. Then once you have these additional models trained, then you have to think about, okay, now I have these models. How do I orchestrate them or agentically use what kind of agentic framework, right? And that's how you finally build something like this, like agentic document extraction. So to answer your question, that's how it goes. That's what we have done, right? What else, Ava? Is there anything else?
No.
Okay, so for ADE, agentic document extraction, I think the most interesting things that you can do is check my notebook, the ADE versus LLM, and then see how you can come up with some interesting comparative analysis and let me know what you find out. And then you can run this whole pipeline on your own documents. I also have something called a synthetic data generator. If you are interested, just email me at ankit.khare@landing.ai. So right after this workshop, I think you will be sent an email or something, and then I can ask folks, the DSD team, to send my email ID, and then you can email me if you want that script, and I can send you that script for generating synthetic data in case you're afraid that you don't want your data into the system, your private data, and you want a synthetic counterpart and play with that, so you can do that. But in any case, the best thing to explore this kind of system is to take some interesting documents or images where LLMs or traditional OCR systems fail, and then try agentic document extraction on them and see what it does, right? And also, if you are interested, if you're an IDP or OCR developer, then another interesting thing that you can do is take my end-to-end workflow pipeline or the custom prompt pipeline, and you can like play with different documents and explore the API features, right? Like for example, alternate name mapping, right? But what we can do right now is I can show you some of the interesting things that I think you would like to see, because in the code, I briefly mentioned how like you can do this, you can do that, but but I never showed it, right? So I think if we go to the playground and see some of that in action, I think that will be interesting. So let's see. Okay. See, this is one of the documents from the previous session that I was playing with. Wait, this got outdated. It's saying legacy. But I think I can still show you. Oh no, I cannot. It's legacy. Okay, what I'll do is I'll re-upload this and show you. Okay, download here, page 1, and then page 2, download. Okay, and then upload file, and then drag them both together, create project. See the first page of EOB document. This is an end of benefit document. You might have seen it. Like if you go to the if anytime you go to your primary care and you use your insurance, you get some sort of end of benefit document, right? Like what's covered, what's not covered and stuff, right? How much insurance paid and things like that. So you see if there's patient, Martinez, and then there are a bunch of columns here in this table. I can actually zoom in.
Ankit, I think your screen is not being shared if you're.
Oh, sorry. That's so
That's okay.
bad.
That's okay.
Okay. So what I did was I have these two documents. I went to the playground, I clicked on upload file, and I uploaded them here. Oh, sorry. Like this. And then I clicked on create project. Okay, if you want to do this, I can give you these files by uploading in my drive the same link that you have. Okay. Here you go. And then it's parsing page 1. You see patient Martinez, dates, codes, amount billed, services not covered, deductible, right? And then on second page, you see the page is continued for the same patient Martinez. 2 fields are here, right? So now intelligently your agentic system should know, your agentic extraction should be able to pick this up and stitch this table together, right? Otherwise, I mean, as a human, it's pretty obvious to you, but for LLMs, when these layouts get complicated, they struggle in like, they would extract as at like separate entities, right? So this is where a lot of production systems struggle because they cannot stitch these values into one cohesive table. But if you see here, now we have run the parse, but what we need to do next is extract. So for extract, if I click on extract, I select these two documents. First step is always to suggest schema. Sorry, have our schema, which I told you can either upload. So earlier we were using the end-to-end notebook for all these things, right? So you were not able to, so you were using API. So you did all this using the API. Now in the playground, it's like more visible and visual, right? So what I did was I generated the schema from scratch without giving it one on my own. What you could have done is just upload your own schema. But what I've done is generated from scratch. And then now you have all these items, all these columns, right? See, I generate for both files, not just one. So it has like one exhaustive, complete schema corresponding to both, okay? Now I will run this field extraction for all the fields on these both pages, files, okay? It's extracting the field, and then you will notice how all the columns will be extracted for the patient together as one key value of one cohesive unit in the form of key and value pairs. Come on. I think I have. Okay, here we go. So here, see, service line items, right? And then you have, for patient Martinez, you have all these line items. And then on the next page, you have again the same key, and you have again the same values here. See, same everything. Here, null is also identified. It's not hallucinating that, oh, if null is not there, then it's like putting something arbitrary here. So that's one cool feature, cross-page table stitching. Another I can show you quickly is, I think, the invoice ones, right? That I told you how like you can have a bunch of invoices with different names of the columns, but it will pick up, right? Let's see if I can show you that. I think I have here. So this is one invoice. I can just download it. This should be another. Oh no, it's not. It's the EOP. I just want an invoice. Sorry, I just am doing things on the fly to show you guys some cool things. Okay, give me
Okay,
1 second.
Gabriela has one question about lab reports.
Tell me. Yeah.
It's actually a long question.
I have a
Yeah.
question, Ankit. In NHS Blood Science Lab, we have external quality assurance reports we receive within the version, and part of my job responsibility is to review and procure EQA review reports. Have you guys had a similar client who uses your AI to do this? Blood sciences for biochemistry differ. EQA assurance bodies produce different units and reports based on hormones. Cool. Yeah, this is a good case.
Yeah, it's like to show yourselves because you're going in the healthcare scheme as quality assurance of laboratories. We have to ensure that anything we're reporting is accurate. And so we obtain samples and we don't know the results, but we actually compare our results to other labs and they give us like report back, it's constant. And because you're proper nerds, you all know your tech so well. I was thinking of that scenario where we have different external quality assurance and it's completely different because some analytes in the blood are expressed in different measuring units. So I'm wondering if this technology, everything's covered. Whatever the external assurance, once we send our results there, they organize it, compare, and then send it back to us. And then we have to present our results on a monthly basis to our internal, our internal teams to say we're confident our analyzers are, measuring well. It gives us a kind of like an alarm bell if something were not right, because how would we know our lab is generating proper results if we don't compare, right? So I'm wondering with this technology, could it be used as an assistant? Because, for example, one hormone could be expressed, is very techy in micrograms per liter, but some reference ranges are in different ways. So do you think there is a capability there for yourselves to use this OCR to review our forms, not to stop us from doing our jobs? We're not replacing our jobs, but just to help us as a reassurance in generating those reports quicker for us.
Yeah, so it's a combination of different things that I've already shown. Like, what you can do is, sorry. See, the confidence scores is a big thing. Since you have, so I'm assuming that you have at least some sort of image or ground truth document where the original values lie, which are accurate, right? Other than that, how would you even evaluate the accuracy, right? So what you can do is you can always use the confidence scores that I showed you and see where the model is feeling underconfident, set a threshold value, like let's say 90% or whatever. And then from there, you will have all those visual places visible to you where the confidence is low, and then you can double check them as a human evaluator. Or as I did in my notebook, let's say you have 3 models evaluating and there's discrepancy between them, right? And the answers are different. Then you can, for all those discrepancies, you can mark them and then go and manually check that, oh, okay, so these are where the models are. With DPT, what you can do is, I mean, right now we have latest model, so we recommend using only one. But then let's say if you have multiple models, you could, like, let's say we are gonna launch 3. You can use 2 and 3, or 2 and 2 latest, and then maybe check the discrepancies and see where the discrepancies are, and then manually go on evaluating them. So these are some ways of like really getting to know where the wrong values might lie, and then have some sort of continuous learning loop established for those specific values and places.
I just know that AI will affect all of us, and some industries are trying to incorporate this to make their life better. But I think there's a different profession within the quality assurance bodies in the United Kingdom and other, that when they assess our labs in terms of measuring analytes, they have already their programs, but in terms of they produce these results and send it to us electronically. We in the lab receive this reports, and it's capturing all that knowledge and experience, because it takes years for us to interpret these results back. And I don't know if that's going to be the future, if they're going to, when we interpret that result, because you know what I've had to do in my, if you're really interested in quality assurance, you sometimes visit the quality assurance companies and ask them, could you show us how to interpret a report? And we go back. And it's only through years and years we build that experience. But again, with your reports, capturing that data and helping us summarize it, it's just interesting, but it's hard.
Yeah, the help that this product can do you is just in the document processing and automation part of those document processing pipelines that you might have already have. So in order to have better accuracy, you can just apply an agentic system like this there that continuously improves, because we keep releasing new models, which means that our already accurate parse and extract are going to become better and better over time. So you get that advantage of like having such system as your backbone for your document processing automation. But let me just finally show you one quick thing about this invoice. So that, see, these are the invoices. I've just taken this one and this one, right? So you have some sort of ID, description, quantity, unit. And in this one, you have consultant role, hours total. So as you can see, it's different, right? The elements are different. Let me just open one more. See services, code, description, units, and here, consultant role. Let's just see how, like, if we have different formats and we build a schema and then we extract fields, what happens? Okay. So what I'll do is go and open the playground again. For reference, I'll add these two in the Google Drive so that later you can play with it. Wait, the same Google Drive. Man, I lost the link. Somebody give me my own Google Drive link. Here. Okay. Dropping these two invoices here. And the same I'll upload on the playground. Upload. Create project. See some sort of ID, description, quantity, unit, price. I don't know, EXT amount. Okay. Second one, role, consultant, hours, hourly rate, and total. Very different invoices. I'm myself curious to see what happens when we extract. Let's see. Suggest schema. Oh, I see. So see, it's still parsing this one. This one is completed. That's why you might be wondering, oh, what's happening? Why is it like, if it's complete, why is it not moving to this one? It's because of the first document. Come on. I think it's taking time because there might be load. So remember, API, the playground is for testing and demo purposes only. The real work, the development work happens in the API. So yeah, so keep in mind that, like, if we are saying that we can handle 1,000 pages, then if you put a document which has like 1,000 pages on the playground and expect that it will work, that's not gonna happen because the playground is only for demo and testing purposes, right? I'm wondering, why is it taking that long? Okay, it's done now. We have the markdown, JSON, all the parsed outputs. You'll go to extract, select both, click on suggest schema. It's generating the schema. I have given it no prompt, so it's gonna automatically generate an exhaustive schema depending upon these two formats that we have for these two invoices, right? Okay. Okay, here's the schema. It's generated. Okay, let's just have a peek at the schema. We have line items with the fields. We have invoice summary. We have sender information, recipient information, line items for the other one, right? So there's no confusion. It's able to identify that these are indeed different invoices, whereas there's no resemblance. right? So it's not hallucinating any common fields here. And so if we run them, you would notice like different fields for different invoices. But if we had something overlapping, I think I picked the ones there was no overlapping. Or if you, let's say, add here, alternative names, and tell it that, hey, this is the overlapping one, or this is the one where I would want to map from this document to this, then it will generate fields for both documents accordingly based on like what alternative name settings you give, right? So what you can do later is upload something that has like, let's say here description, instead of the description or quantity, it says number, or here instead of description, it says something like item description, right? And then see, or upload the same thing, but with different, what do you call it? The column name, and then see what it does, if it's able to map it or not. So that's what I wanted to show you actually, but these are significantly different. So it's not confusing, that I have shown you, but I don't have any such invoice where it's like significantly similar to show you. But yeah, try some of them, or just use my synthetic data generation script that I'll send you after this call, and see if you can generate something with almost everything identical but different names, and see if the schema generation API identifies that mapping automatically or not. Cool. Okay. So this is it. I think we are running out of time. Let's just take a bunch of questions if you guys have any before we call it a day. Okay, I think everything is answered. I see one question: how do you deal with the case that the same table is parsed to different chunks? If you're referring to the same table on different pages thing, and you think that, okay, we might have one chunk for the table on previous page and another chunk for the table on the second page, but with the same headers or columns, and there are two IDs for them, then what will happen, right? I think that was your question. So for this, like as I showed you, it will have a reference even if it has different chunks. I have not tried it. I have not found it any case where like the chunks are different and that sort of dynamics happen. But for sure, even if the chunks are different, there will be reference because of the same header identification. So it will automatically be able to deal with it. Try some document like that if you have any. It will be able to automatically detect all those connections.
For the table that appears on the same page, do you have any mechanism that during the parsing you can still keep all the content of the table together in one chunk?
It does, yeah. So if let's say the headers are constant, there's no variation, then what will it do is it will have the same fields, same line items in the extractions, and from those line items you will always see, like, let's say, as I showed you, let me share my screen again. This one, EOB, right? Extractions here, and then here. In extraction, you don't really have any chunk ID that you care about. What you care about is, do you have the same keys, all these, right? So look, like suddenly the value changes, but the keys are constant, right? See, that's what you need to stitch, because now you don't have any confusion of two different fields for the same things. Because if the system would not identify that these columns are the same, then it will create different fields, right? So the very reason it has the same constant fields is because it has identify. So that's the answer for your.
Yeah, so it seems the mechanism is a bit different from the reg for text. For text, it's like each chunk we set a fixed chunk size, but here it seems like finding the area or bounding box of that table. So each chunk, the chunk
Here?
size is bit, yeah, it can be different, right? You don't need to set a fixed like number of token for number of tokens for that chunk. For each chunk, we don't need to set, right?
So here okay, so for parsing, chunks are needed. Okay, here, let's see. Metadata. Patient name, patient ID, claim type, reference. See, this is a reference. This is the information that you will need to ground this. Like, where is it coming from? This is the reference information. See here. That this is coming from here, this is coming from here. So that's how the references work. So you need only like references for visual grounding, right? So that's what is happening here. It has references like this cell here for this field, this cell for that field. So think of it like not in terms of chunks, but in terms of references and schema, because in field extraction, your schema is the template. So if your schema is right, then the extractions are gonna be consistent. Right?
Yeah,
So
that
if your
makes
schema
sense.
was
Yeah.
made right, then no matter how many, like if you have, let's say you have a new document and there's slight variation, and then you again, so that's what we call schema drift. So now your schema will be drifted because of slight variation. So what you can do is build again a schema, taking in consideration all those new documents, and then you can work on them. Right? So think about like in terms of schema for field extraction, not like chunk and references. But for parsing, it's a different thing. For parsing, it's chunk IDs, and then within those chunks, other things.
Okay, thank you for the explanation.
Somebody like, if you want to just extract a description and amount from both invoices in one table, how extract a description and amount from both invoices in one table, how? Yeah, so that's what we did. We extracted on both page in one table. So the same keys, but different values. So your tables move like this, your keys, the values were moving like that. For the second page, the same, right? So that's what we did. Okay. What else, guys? Anything else that's unclear?
Hey, Ankit, I was just thinking about this from a consumer or a client point of view, and really all they care about is the end product, right? So isn't that where we should concern ourselves is with the extraction? I mean, understand the parsing, but that's like the black box to the client. The extraction is what they care about. So we got to make sure our extraction is dialed in, so that way it's as accurate as we can possibly get it, correct?
See, extraction is built on parsing. So the building block of extraction is also parsing. Like the structure of the document is analyzed during the parsing phase. And then from that structure out, from that semi-structured output, which has all the structural metadata information along with the text, right? You go and extract specific fields, because when you have some specific fields, you need to really understand the spatial arrangement of those fields, where they are in different pages, across pages, what is the relationship, and a lot of other things. And then for that to happen, you need to have accurate parsing as well, because the extraction agent is actually referring to the parsed output for understanding all that spatial arrangement and correlations. So it's very interdependent and connected, where the parsing forms the basic building block for extraction. But from the end client perspective, yes, like if let's say they're only interested in a bunch of fields, they use the extract API. The extract API automatically calls the parse API, get the output, build upon that depending upon their schema, and give them what they need. So in that sense, they might not really care about the intermediate parsed output as much, but they would care about, okay, if we are getting our fields right or not. So in that sense, yeah. Does that
Okay.
answer your question, Scott?
Yeah. Oh, perfectly. Yes. Thank you very much. Now, well, I understand I understand more that parsing is just as important from our point of view as extraction, because without parsing, you don't have extraction, or at least not accurate extraction at all. So you're just basically throwing whatever form in and you're getting whatever junk out. So with parsing, that takes that form, makes it readable for the API, for the LLMs to do the agents, I should say, to do their work and then extract it accurately or as more accurately as possible. Then we can fine tune that over time. So if we got a consistent form, we're feeding it all the time. We can fine tune that extraction or the schema so that that extraction and parsing is giving them basically 100% accuracy over the long run.
Correct. The only part is the fine-tune one. Like in machine learning world, you use the word fine-tuning in the model training sense, where you're basically tuning or tweaking the models of or the parameters of the machine learning model. You call that process as like fine-tuning, maybe like unfreeze some neural networks layer and then tune it for the new data. Here, it's a little different. Here, it's not like it's more like it could be different kinds of things in the tuning phase, right? Like it could be the agentic reasoning is, it's like getting better. It could be the one of the models in the agents orchestration processes are getting better. The LLM model might be getting better. A combination might be getting better, right? So it could be a bunch of improvements in different dimensions. It's not just the fine tuning, right?
Okay, so
Yeah.
if the end result is 100% accuracy, let's say you got the same document, it's the same format, the same data, just obviously it's different for each customer, let's say, right? But let's say it's an invoice, same format, same information, or I'm sorry, same headings, same type of information, identical. Every form you're doing thousands of them. So you just want to dial it in so that way your schema, right, is dialed in so that it understands that specific format 100% of the time, and then you should get your accuracy should be really close to 100%, correct?
Correct. It should be close to 100% right out of the box. And if it's
Oh,
not
okay.
from some fields, then you should have a way to backtrack them with some sort of confidence score. And then that confidence score should have a threshold where you can say that, okay, now less than 90%, I'll put a human evaluator. And then you have that human evaluator for those specific less confident extractions. And then you go from there. Yeah.
Okay, perfect. All right, thanks.
Yeah. Anyone else? Anything else? So, folks, the last departing words, I'll just share my slides again and close this. This is my previous workshop at Data Science Dojo as well, where I go deep into parsing and how, all those three things associated with the paradigm shift, visual AI first, data-centric practices, and agentic orchestration, right? And how and then how LLMs struggle because they don't have those three things as explicitly for document processing, right? So if you're interested, you can watch this. Then you have another workshop that Andrea did, I think yesterday. It's about self-improving pipeline. So she explained that, and I think that could be interesting for you if you are in IDP and OCR world. And what else? There's some more slides here. I showed until here, but then there are more stuff here. So if you're interested in reading out, then you can always refer to these slides if you're interested in what are some of the use cases. Because the workflow remains like the same, right? Like you have some form of parsing and then extraction or just parsing, right? We didn't talk much about split, but in these workflows, split also comes into play sometimes. So, but yeah, if you're wondering about those use cases, some slides for you as a food for thought. And then, what else? One last thing. We have tutorials from Ava, who is our growth engineer, who has written some really interesting blogs on called ADE Storybook. Let's see where they are. Here. So there are some interesting articles here. What you can do is just type LandingAI/blog and it will take you here. And you can read about like why long documents break extraction systems, why extraction breaks when schemas drift. So a lot of things we discussed, but if you want to go and read more on that, then here's the thing. And then there's the AD Storybook. Where did that go? Okay, let's just search. Here, part 1, 2, 3, 4. So that's like a more storytelling kind of a theme to understand parsing, extraction, split, and other bunch of things. Okay, so feel free to go through them if you're interested. And a last thing, like we have our new community manager, Chin, who is very active in our Discord community. So join our LandingAI server. So on the website, you have something called, even in the product, wait, let's just go here. See here. On your account, you have community. You click on here and you will get to the, another interesting way would be just go to LandingAI website, landing.ai, click on resources and click on Discord. So there are different ways of joining it, right? And then in this server, you can get all your questions answered. And we are planning different things like office hours, weekly webinars, and hackathons. And we share all those things here. And a bunch of people are active here who keep talking about different OCRs and different intelligent document processing systems and different things pertaining to creating document workflows and automations and stuff. So if you're interested in those things, don't miss this server because a lot of like-minded people who are actively exploring are here. So yeah, I think that's all for me for today.
Thank you so much, Ankit. So we'll wrap up with that. We'll wrap up our today's session. A big thank you to Ankit for such an insightful and hands-on workshop, and also to the entire team at LandingAI for supporting the session. And of course, thank you to all of you for joining and staying engaged throughout. And we really appreciate your time and participation. If you'd like to stay connected and be a part of our community, we'd love for you to join our Discord, where we'll share latest updates, resources, and upcoming sessions. Just a small request before we conclude, we'd love to take a group picture with everybody along with the team at LandingAI. So if you're comfortable, please turn on your cameras and we can take a quick picture and then we can conclude the session. Does that sound good?
Yeah.
All right.
Okay, folks, thanks for coming and
thank you so much.
Feel free to write me, okay? If you have any doubts. I am always on Discord and my email you can get from Radhika. Okay? Cool. Ciao. Cheers. Later. Bye.
Absolutely.
Bye.
Thank you. Thank you so much. Bye-bye.